Okay, good morning, everyone. Before I get started, are there any questions? No. Okay, well, today what we're going to do is we're going to talk about long division. We're going to talk about synthetic division, how this all ties into factoring. And then next class, what we'll do is we will continue sketching polynomials. We had started that last time. And as we were doing the process of sketching polynomials, we ran into a problem, I'll show it to you in a second, where we didn't know how to factor something. And so what we need to do here is like stop, take a look at this new way of factoring using this thing called synthetic division. And then once we establish this new technique, we'll go back to the sketching of the polynomials. I did adjust the homework due dates. R4 and R6 are now due on Sunday night, and I will cover that material today. So R4 is long division, R6 is synthetic division. So that's our plan. We'll get started. Remember last class, we were working through a problem. We were trying to sketch this polynomial function, and we were using these steps that I had given you last time. Where is it here? Where are my steps? Here are the steps. How to sketch a polynomial. We determine the end behavior, and then I said the hard part is going to be the finding the x-intercept, setting the function equal to 0. And so we were working on a problem. We had done a few that we could factor and everything was fine, but we ran into this one and we didn't know how to factor this. We tried maybe doing grouping, or we didn't do it, but we talked about grouping, but grouping doesn't work here. So this is where we're going to just start, kind of like clean the slate. Let's start with a fresh idea here. I want us to go back and think about just numbers in when we divide numbers. So if I take the number, let's say 15, and I divide that by, let's say 3, we all know the answer is 5, right? But back in grade school, what we did is we took the 15 here, we put the 3 out here, and then we asked ourselves, okay, what do you multiply 3 by to get 15? And you say, oh, well, 5. Then you multiply 5 times 3, put 15 here, subtract, and get 0. So you would have a remainder of 0. That look familiar, everyone? I know this seems very basic, but trust me, it'll be helpful in a minute. So what does this mean? Okay, what does getting a remainder of 0 mean when you divide a number like 15 by 3? Well, what it means is this. What we can take from this is that if you take this 3 and you multiply it times this number 5, you should get back the 15 here, right? That's what it means. So really another way to kind of look at this is we have taken the number 15 and we have broken it down into a product, right, of two things. This is called a factor, and this is called a factor. So we have rewritten some number in its factored form, 3 times 5. So somehow doing division allows you to take something and factor it. What we're going to be doing is not numbers. We're going to be trying to look at polynomial expressions and factor them. So we're going to need to somehow use division to achieve this same thing. Let's look at something that's that doesn't divide in evenly. So let's stick with 15, but now let's divide it by 4. Okay, so if we do this old school, 15 here, 4 here, you say, well, 4 doesn't go into 15, not evenly, right? Not without something left over. So, or 4 times 3 is 12, and 4 times 4 is 16. So there's no number that multiplies to get exactly 15. So we go and we say, okay, 3 here, multiply 3 times 4 to get 12. We subtract this row, we subtract, and then we get 3 here. And since 4 doesn't go into 3, we would say our remainder is 3. Because the remainder is not 0, right? This is not 0. that means we cannot break the 15 down, right? 15 is not 4 times 3. And the thing that indicates that to us is that the remainder isn't 0. Anytime the remainder is 0, then we can say, oh yeah, it breaks down to these two numbers multiplied. Does that all make sense? Yes, okay. So how in the world are we going to use this to factor something? So I want us to look at this problem here. Let's say we wanted to look at x squared minus 2x minus 3, okay? And I feel like a lot of you could probably factor that if I asked you to. That I'm not asking you to think of that right now, but I want you to take this and I want you to divide this by x minus 3, okay? So what we're about to do is referred to as long division. This is exactly what we're doing right now, long division. Okay, long division. So we're going to do it just the way we did before. We're going to put the numerator will go into the division box. So I put x squared minus 2x minus 3. And when you put that into the when you put it into the division box, it must be in descending order. That means highest power of x from the left to the right. So x squared, then your x term, then your number by itself. If you mix up the order, long division is not going to work. And then on the outside, we put the x minus 3. So the way you do this is you look at just the first term here, x, and you look at the first term here, x squared, and you ask yourself, what do I have to multiply x by to get x squared? Well, I'd have to multiply times x, right? That's how I could turn x into x squared. So up here, I put an x. And it doesn't matter where you put it. Some people say, you know, line it up with your x's here, like you're above the negative 2x. You don't have to do it. It can go anywhere. Doesn't matter. Okay, so just like we did before, once we have this number, like, you know, like here, when we did 4 times 3, the next thing we did is we multiplied the 3 times the 4 and we put that 12 underneath, right? That's what we did. We're going to do the same thing here. We're going to take this x and we're going to multiply this x times this entire thing. What that really means is this. We're going to take x and multiply it by x minus 3. So you have to multiply it times both. So you get x squared minus 3x. And that's what we will put underneath here. Okay, so I'm going to put that in a different color. I'm going to put, okay, we get x squared, we get minus 3x. Any questions there? Now, what did we do when we did this back in old, you know, elementary school? We did 4, we said 3 here, we multiplied the 4 times 3, we got 12. And then didn't we subtract this? Didn't we subtract the 12? That's exactly what we're going to do here. We have to now come through and subtract this, which is going to change the signs. It's going to change that positive x squared to a negative, and it's going to change this negative here to a positive. And then what we do is we add straight down. So if you take x squared and take away x squared, these go away. If you do negative 2x and you add 3x, you get just a single x. And then you have negative 3 and you're not doing anything. You're not adding or subtracting anything from it. So all you're going to do is just have minus 3 here. Hold on a second. 2x minus 3. Okay, yeah, all right. Now what? We repeat the process, okay? We repeat the process, and that means we are going to look at this x again and ask ourselves, what do we multiply it by to get just the first term of what we have down here, x? So what do we multiply x by to get x? 1, right? So what I'm going to put up here is plus 1. And now I play the same game. I take this 1, positive 1, and I multiply it times this again. All right, that would mean I do 1 times x minus 3, which just gives you x minus 3. That's what I'm going to put on below this, x minus 3. And then as before, I'm going to subtract this row. So I come through here and I subtract it, which changes this plus x to a minus x and changes this minus 3 to a plus 3. And then I add down again. And when I add down, the x's go away and the negative 3 and positive 3 go away, and I have a 0. And that means my remainder is nothing, right? My remainder is nothing. So I'm going to put next to this what we did a second ago. When we were doing 15 and we divided it by 3, we had 5 here, we had negative 15, 0, we had a remainder of 0. And what that allowed us to say is that 15 could be written as 3 times 5, right? That's what it meant. So what this is telling me is that the numerator, this right here, could be rewritten as these two things multiplied. I'm running out of colors. It could be written as, let me see, these two things multiplied, right? Those two things multiplied should give me what's underneath here. Just like the 5 times 3 should give me the 15. So that means if I take the x minus 3 and I multiply it times the x plus 1, I should get back this. And do you see what I've done is I have factored? Do y'all see that I have taken this quadratic and in some sense I have factored it now? Now this is at least when you're looking at this initially, you're like, well, this seems like a pretty inefficient way to factor because this takes a long time. We are going to have a shorter method for this, a quick, fast way of doing it. That's what synthetic division is. Long division, though, you have to know how to do it because in future classes, synthetic division can't be used, all right, in some aspects of calculus. So that's kind of the big picture. I mean, the answer to the problem here, okay, if somebody were to ask you to do this, if someone were to ask you to take this and divide it by this, your answer would just be what we got up here, x plus 1, okay? Just like if I asked you, you know, what's 15 divided by 3, your answer would be 5, okay? So the answer is this. However, this is the big takeaway, is that it gives us a way to factor. Understand? All right, let's do another one. I want us to take 6x cubed minus 7x squared plus x plus 1, and I want us to divide it by x plus 2. All right, so first things first, draw my division box. The numerator goes in the division box. Put it in descending order. On the outside, I put x plus 2. Okay. Malak, are you there?
Yes, I'm here.
Okay, are you following?
Yes.
Okay. So what am I going to do now? I've got this set up. What am I going to do?
You're gonna see how many x's can go into 6x cubed.
Yeah, so how do you turn x into 6x cubed? How are you going to do that? You have to multiply x by what?
Don't you multiply by the 3 to get the x cubed? Or the 6x?
You'll need a 6 because right now all you have is x, right? So you'll need a 6 to turn that into 6x, right? 6, and then you need x cubed. You already have 1x, so you'll need how many x's?
X squared.
Yeah, x squared. Good. Okay, so if we multiply x by 6x squared, we will get 6x cubed. And now we have to take this and multiply it times these two. Okay, now you can write it off to the side if you need to. Okay, you can do this and then you can distribute it like that and get your 6x cubed plus 12x squared, sorry. You can do that, or if you don't need to write it down, you can just do it kind of mentally. You can just be like, okay, I'm going to take this times that. That's 6x cubed, put it underneath here. And then you could go, okay, now this times this, and that gives me plus 12x squared. And notice I'm lining everything up. My x cubes, I'm putting my x cubes together in a vertical column, and I'm putting my x squareds, you know, vertically below, above and below one another. Okay, good. Sierra, you there? Okay. How about Dominic? You good with this so far, Dominic?
I think so. I learned it a different way, but it's kind of, so I'm still like, I'm like regaining it, regaining it all.
Okay. What do I need to do? I mean, Malak helped us get the 6x squared, right? And I multiplied it through and got this. What's the critical next thing I have to do?
Oh, you gotta subtract it all.
Subtract it. Okay, good. So when you subtract it, it really just changes the signs, right? That's all it does. So if it was positive, it now becomes negative, right? So tell me what would, Dominic, what would my next line be?
It would be, would it make it a negative 19x squared?
Yep, negative 19x squared.
Then the
Okay.
plus x plus 1 drops down.
Yep, plus x plus 1 drops down. Good. Okay. Everyone on board? I'm going to try and get through everyone today. Let me see. Sana, you there?
Yes.
Okay, you following?
Kind of, I was driving on my way to school while I was on Zoom, so I just got here, but I think I can do it.
Okay, so what am I trying to do now? Like at this point, what am I looking at? What are you looking at? What are you trying to accomplish here?
With the 19x squared.
Mm-hmm. With this negative 19x squared.
Let me see. So is it to see if the x plus 2 can divide into it, or would it be the 7? Or no, not the 7.
All you look at is the x up front, and
Okay.
you ask yourself, what do I multiply this by to get this? Okay.
Oh, negative 19.
Negative 19, that would give you a negative, that would give you the negative 19, but you need an x squared and you only have an x. So what are you going to need to multiply that x by to get x squared?
An x.
Yeah, just an x, right? Okay, so that's it. Negative 19x. Sana, does that make sense?
Yes.
Okay, everybody? We're going to do the same thing. We're going to multiply negative 19x here and negative 19x here. So when I do negative 19x, and you have to include the negative 19x times x, that gives me negative 19x squared. And then negative 19x times positive 2 gives me a negative 38, negative 38x, right? Lizeth, you there? Javier,
Yes, sir.
what now?
You would subtract it, or you have to change the signs.
Okay, yeah, so we're going to subtract it, which means change the sign. So the minus becomes a plus, the minus becomes a plus. Tell me what my next line is.
Would it be positive 39x
Mm-hmm.
plus 1?
Plus 1. Okay, good. Okay, Javier, what would you do now?
See how many times the x goes into the 39x.
Okay, and so what would you need in order to turn this x into 39x? What's the only thing you're missing?
Multiply times 39.
39, right? Because you already have an x, right? You already have the x. You just need to turn this x into a 39x, so you just multiply by 39.
Yes, sir.
Okay, good. I don't know. I mean, it's for some reason, students don't like long division. I'm not quite sure. It's always this thing. It's like, oh, I hate long division. But really, it's just as long as you're like paying attention to what you're doing and the signs and everything, and make sure you subtract each row or change the signs. It's pretty methodical. Alyssa, you there?
Yes, sir.
Okay. Are you following?
Yes, I think so.
Okay. So what would be my next thing? Javier just said we're going to need to multiply this by 39. So what are you going to do?
Multiply 39 times 2.
And the x, right? Both
Oh,
of them.
yeah, and the x.
So first the 39 times x, I'll put that here at 39x. And then I'll do 39 times 2, which is 78.
Oh, sorry, I didn't know you were asking me. I thought you were doing the math.
I was doing the math in my
Sorry.
head. Yeah, 78. It's okay. 78, right? We're all okay with that? Okay, then we will subtract it, right? So don't forget this step of changing the signs. And now when you cancel those out, you get -77. Now look, we need to continue this process. We have to keep going. The question is, when do you stop? And you will always stop when you can't turn your x into what's down here. So like I have a -77, right? I cannot multiply x by anything to get -77. I can't, because this doesn't even have an x in it. So at this point, I'm done. And this is my remainder. Okay. So what I would put here is my remainder is -77. Notice the remainder is not 0, right? It's not 0, which means that there's no way that you can take this numerator like this up here is not equal to x plus 2 times 6x squared minus 19x plus 39. Like this is not true, because the remainder was not 0. If the remainder was 0, then I could say this, but it's not. So that's not true. So it doesn't factor this way. Does that make sense? We need the remainder of 0 for us to be able to say it factors. But we do have an answer to the question. The answer to the question is this. The answer is, well, we got 6x squared minus 19x plus 39. Now we have a remainder, right? We do not write r -77. We don't do that. We do that in elementary school. We don't do it here in college algebra. What we do is instead is this. We put plus, and then we put the remainder, -77, over the divisor x plus 2. So whatever you get here at the end, you divide that by this. Okay, that goes here, that goes there. Do y'all see that if your remainder was 0, you wouldn't have anything here, because you would have 0 over something that would be gone, so you wouldn't have anything left. But because we have -77, we write it this way. You can think of it this way if you like. If we go back to, let's say, 15 divided by 4, when we did that, we said, okay, here's 15, here's 4, 3, this was 12, we subtracted, we got 3, we said remainder 3. So you could say that 15 over 4 is 3, but instead of putting our remainder 3 like this, we would put plus 3 over the divisor, which is 4. So 15 divided by 4 is 3 plus 3/4. That's what it really is. Now, here's something you may or may not know. Another way to write this is 3 3/4. This is called a mixed number. And mixed numbers are nice in elementary school. Mixed numbers are no good in higher level math. I mean, we still use them, but in calculus, we don't use them at all. Like, we hate mixed numbers. And the reason why we hate mixed numbers in higher math is because when you write 3 with 3/4 next to it, a lot of people would interpret that to mean 3 times 3/4. And that's not what it is. This actually means 3 plus 3/4. So it's really a bad notation because it can be confusing in calculus, because two numbers written like that next to each other, you would think means multiplication. It's like implied, but that's not the case. So we kind of throw away mixed numbers. Here we don't want to use them. All right, but I want you to understand that's what it means. Okay, 3 3/4 means 3 plus 3/4. Okay, making sense? Any questions? Got another one for you. Let me see. Are we gonna get? Yeah, here's a good one. I'll throw you into the frying pan here. How about this? How about 6x to the 5th minus 9x squared plus 9x. I'm just pulling some problems out of the homework. All of that divided by 3x cubed minus 1. So I want us to divide this. All right, for the first time, this is the first problem we've had where we have something unique happening, something different. When I write my division box, watch what I do, okay? I need it in descending order. So 6x to the 5th plus, watch, 0x to the 4th plus 0x cubed minus 9x squared plus 9x plus 4. Okay, I did something different here because in my original numerator, I did not have an x to the 4th or an x cubed in the expression, right? It was missing. But in the long division, I included them by putting 0x to the 4th plus 0x cubed. The reason I did that is because when we do the long division, it is possible that when we get some number up here, or whatever it is we get up here, when we do that multiplication through, it is possible that we might get an x to the 4th or an x cubed. It could happen. And if it does, I need a place to put it. I need to line it up with any other x cubes or any other x to the 4th. If you don't put that in there, you're not going to have a space for it. So it's important that when you're doing long division, you account for any missing powers of x with zeros in front of those. Now on the outside, I have the 3x cubed minus 1. I don't know if I mentioned this. If I didn't, I'll state it. Both of these have to be in descending order. Both what's in here and what's out here. Both of those are in descending order. So highest power down. Okay, let's see here. Miguel.
Would it be 2x squared?
2x squared, what do y'all think? Yes, no, yes? Yep, okay, thumbs up from everyone. 2x squared, good. So in order to turn 3x cubed into 6x to the 5th, you had to turn the 3 into a 6, so you had to hit it with a 2. You had to turn the x cubed into x to the 5th, so you had to hit it with x squared. Good. Now, go ahead, Javier, Miguel, sorry, and multiply that. Tell me what I'm going to write here.
You'll put 6x to the power of 5 minus 2x squared.
Minus 2x squared. And I'm going to put that minus 2x squared underneath the x squareds, right? I can line it up under the x squareds. Good, good. And Raquel, you there?
Yes,
You following?
yes, I'm following.
Okay, what's the next step?
Uh, wouldn't you have to find the number that makes it to X4? It
So-
would be,
Well, let's see. Miguel told us to multiply this through, which we did. Right, we did. And then now we need to do something before we start looking at what to multiply anything by.
so then we would just subtract the
Yeah,
6x5,
subtract, change that to minus. What do I change this to?
a positive.
Positive, okay. And then go ahead and add down. Tell me what this next row is gonna look like.
Well, the 6x5s are gonna cancel. And it would be negative 8x squared.
-7,
Oh, 7, sorry.
7x squared. And then what about these two?
And then we just bring those down.
Bring them down, yeah. Okay, good. Now, at this point, this is where you look at the 3x cubed and you say, okay, how do I turn it into this? Okay,
Yes.
and we can't. The reason we can't is because this is an x cubed and this is an x squared. And since this power is smaller than this power, there's nothing I can do to multiply this x by anything to make it a smaller x. I can make it a bigger x, but I can't make it smaller. So this is the remainder, everyone. Okay, that's our remainder. So what I'm going to do up here is, instead of writing R with all this, I'm going to do what I just told you. Put plus, you put the remainder over the divisor, which was 3x cubed minus 1. And that's the answer. Okay, this right here is our answer. That's what this is equal to. So again, it doesn't factor because my remainder wasn't 0. Questions? You ready for me to give you one? See what happens with this one. Okay, I want you to do 8x to the 4th minus 4x cubed plus x plus 5. I want that divided by 8x squared plus 8x plus 9. Pay attention, okay? Pay attention. Be careful. Take your time. I'm going to put up a poll. When you're done, click yes to let me know you're done. All right. I'll call time when we have at least like 12 of y'all done. We have 4 students done. Okay, I think I'm gonna, because it's already been 6 minutes, I think I'm gonna walk through this because I already know where some people are having trouble. So let's just make sure you've got what I've got here. You've got your numerator. Make sure you had that 0x squared in there, right? Because you were missing an x squared. And then the first step is to try and figure out what you multiply 8x squared by to become 8x to the 4th. Well, you already have the 8. So all you need is an x squared. So I put x squared here. And then I multiplied that x squared through. Here to here, that gave me the 8x to the 4th. Here to here, that gave me 8x cubed, positive. And then here to here gave me 9x squared. And I put that underneath that 0x squared. Then I subtracted all of the row. So these two canceled. These two together become negative 12x cubed. These two together became negative 9x squared. And then we brought the x and the 5 down. Everyone good up to that step? Any questions there? Okay, here's where most of you probably had some issues. We have to try and turn 8x squared into negative 12x cubed, right? That's what we have to do. Well, it's not easy to turn 8 into negative 12, right? It's not easy, but you can do it, all right? The question is, what do we multiply 8 by, right, to become negative 12? Well, you can turn this into just an equation. You're trying to figure out what you would multiply 8 by to become negative 12, right? 8 times what is negative 12? If you divide both sides by 8, then you know what you need. You need negative 12 over 8, which reduces as a fraction, right? You can reduce this fraction. 4 goes into both of those, so negative 3 over 2. So I'd have to multiply 8 by negative 3/2, which is a fraction, which sucks, but that's what I would have to do. I'd have to multiply by negative 3/2, and then I would also need an x, because I'm trying to turn the x squared into x cubed. Any questions on that?
Would you write it over the 0x squared or would you write it over the x?
It doesn't matter. Yeah, that's what I was saying earlier. It doesn't matter where you
Okay.
write it on the top, because it's just your answer. I know some people, when they teach it, they say, oh, put the x squared on top of the x squared, you don't have to. There's nothing. Now, you do need to line these up. Under here, you need to line those up for sure. Okay, so now I've got to multiply this times this, this times this, this times this, and that's going to suck, okay? It's going to suck. In fact, I'm going to do it on the side. I need to multiply negative 3/2 x times 8x squared plus 8x plus 9, right? That's what I need to do. So I distribute this through here to here. So how are you going to multiply that? You have to take negative 3/2 x and multiply times 8x squared. You know you'll get x cubed, but you've got to multiply negative 3/2 times 8. So negative 3/2 times 8 over 1 is the way you could look at that. And you can multiply across right now and get negative 24 over 2, and then reduce the fraction to negative 12. Right? So when you multiply that first one there, you get negative 12x cubed. Then you got to do this to this one. And because it's an 8 again, we should get the same answer, negative 12, but then x squared. And the last one's going to be the one that really sucks, because we've got to do negative 3/2 x times 9. And unfortunately, when we do negative 3/2 times 9 times x, this does not turn into a nice number. That's just negative 27 over 2x. And I'm not going to use decimals or anything here, all right? Are there questions? Because I realize this is tricky with the fractions. Are there questions?
Question.
Yes,
Do we have to reduce the fraction if we can every time?
I recommend it just to make your life easier later.
Okay,
I would reduce the fraction. It wouldn't be wrong if you did not.
okay,
You could just make your numbers kind of big later.
okay.
Let's see where this goes, okay? This is what needs to be put in here underneath. So I need negative 12x cubed here. I need negative 12x squared here. I need minus 27 over 2x there. And then I have to come through and change the sign, subtract. So this becomes plus, this becomes plus, this becomes plus. And now I add down. The x cubed stuff goes away. I'm gonna get 3x squared because I take negative 9x squared, add 12x squared, I get 3x squared. And then this one is not fun, okay? This one right here. Oh, sorry. These two added together, I'm taking 1x and I'm adding 27 over 2x. I'm taking 1x and I'm adding 27 over 2x, which means I need to add the two numbers together, right? Because like 3x plus 2x is 5x, you add 3 and 2 together. So I need to add those two fractions, 1 plus 27 over 2. That's the same as common denominator, 2 over 2 over 27 over 2. That's 29 over 2. That's what happens. I get 29 over 2x plus 29 over 2x. Then I bring down the 5, plus 5. Well, this is a pretty rough problem, huh? This is right out of the homework, so yeah.
Wait, I have a question.
Yes.
How did you get the 2 over 2 again from the 1 plus 27 over 2?
I'm trying to add two things together, right? You can look at the one,
Uh-huh.
you can look at this one as being a 1 over 1. And then you have to get a common denominator,
Oh, okay.
right? So I just
yeah.
rewrote 1 over 1 as 2 over 2.
Okay.
All right, we got to do this again. We got to figure out how do we turn 8x squared into 3x squared. And there's a way to do it. I have to multiply. Does anyone know? What do I multiply 8x squared by to get 3x squared?
3 over 8.
3 over 8. Good. 3 over 8. Because you're trying to turn the 8 into a 3, right? The x squared is already here. So I just have to multiply the 8 times 3 and divide by 8. It'll cancel. We're doing 8 times 3 over 8. The 8's cancel and you just get a 3. Now you could do that the way we did this. You could say, okay, I'm trying to turn, I'm saying 8 times some number equals 3 is what I'm looking for. And then you just divide both sides by 8. And you get, okay, it must be 3 over 8. This problem sucks because of the fractions, right? I mean, that's really what makes this really messy. That the numbers don't work real nice. All right, so now I've got to take 3/8 and multiply my positive 3/8 through here, through here, through here, right? And I'm running out of room. I'm going to squeeze that up here. Let me use a different color pen. Let's try this brown pen. I've never used the brown pen. So I'm doing 3/8 and I'm multiplying it times 8x squared plus 8x plus 9. So when I distribute here, I get 3x squared. When I distribute here, I get 3x. And when I distribute here, I get 27 over 8. I cannot reduce that. So I'm not showing the work there because I did it down here. When I distributed here, I kind of showed you how to do this. You have to do 3/8 times 8, 3/8 times 8, 3/8 times 9. So that's what's going to go down here. 3x squared plus 3x plus 27 over 8. Now I come through and I change the signs. Minus, minus, minus. The x squareds cancel. This is going to be the last step because now that the x squareds are gone, when I add these down, I'm going to have an x term and I'm going to have a number by itself. And I won't be able to turn 8x squared into this because it'll be, you know, less than x squared. It'll be just x. So this is going to be my remainder, but I've got to figure out what it is. All right. So let me copy this real quick. Oh, that was perfect. Let me copy this and just do it down here real quick. I need to do these added up right here. So let's do those. I need to take 29 over 2x and subtract 3x. So really I need to look at the two numbers, 29 over 2, and I need to subtract 3 over 1. So I get a common denominator, 29 over 2 minus, I multiply the top and bottom by 2 there, I get 6 over 2. And then once we have the same denominator, you just do the 29, take away 6, which is 23 over 2. So this should be 23 over 2x. And then the other one I have to do is 5 take away 27 over 8. Again, I have to get a common denominator. So I rewrite 5 as 5 over 1, multiply top and bottom by 8. I get 40 over 8 minus 27 over 8. This is, what's that? 13 over 8. So, sorry, yeah, positive 13 over 8. So plus 13 over 8. The remainder is not 0, right? The remainder is not 0. That's the important thing. So we know it doesn't factor, but we do need a final answer here. So let me just, I'm just going to copy this. This is what goes here. Okay. So my answer is this right here plus the remainder 23 over 2x plus 13 over 8 over the divisor, which was the thing on the outside, 8x squared plus 8x plus 9. Yikes. Not pretty. I'm looking to see if I want to do any more of these off the homework. Give me a second. Yeah, that was a tough problem. I would say that's probably the hardest problem on the homework assignment that I can see. Let me do one more. This one's going to look a little strange. I want us to take x squared minus a and divide it by x minus a. So don't freak out, you know, because we don't have numbers there, right? X squared minus a, minus a squared. I meant to put a squared there. X squared minus a squared over x minus a. Let's just do the long division. So I have an x squared. I don't have any x's, but then I have a minus a squared. So we're treating a as if it were a number, some constant, okay? And then on the outside, I'm going to put x minus a. That makes sense, everyone? What do we multiply x by to get x squared? Just x, right? Just x. So I put x here. And now I multiply x times x, that gives me x squared. And then what's x times negative a? Negative ax or negative xa, right? Where do I put that? When I do this times this, I get negative ax. But where do I put it? Do I put it underneath the 0x or under the a squared?
Zero?
Yeah, under the 0x, because negative ax has an x in it, right? So I'm going to put here minus ax right there. Now I subtract. So it turns it into minus here and plus here. These cancel. Nothing plus ax just gives me ax. And then I still have minus a squared to come down. Questions? Play the game again. What do you multiply x by to get ax?
A.
Just a, right? Plus a, so plus a. Okay, so now multiply a times x. That's ax, so I put it underneath the other ax. And then a times negative a, which gives me negative a squared. Come through, subtract, which means you're going to change that to minus and change that to plus. And do y'all see what happens? You get what? Nothing, right? Zero. You get zero. So the answer to the question is this. The answer is x plus a, right? That's what the answer is. It's just this because there's no remainder. But what that really means is that if you took this numerator, you could, if you wanted to, rewrite it x squared minus a squared. You could write it as, oops, I don't need the parentheses. You could rewrite that as what times what? Because our remainder was zero, we could rewrite the top as what times what?
X minus a and x plus a.
Yeah. Do you recognize this? This is the difference of squares formula, right? When we factor a difference of squares, we use this formula, right? I'm just showing you with long division why it is that. Like, I'm confirming that it works. Okay. We have about 40 minutes or so. That's it with long division, all right? Long division can be tedious, especially if there's fractions. You have to be extremely careful. There's a lot of arithmetic you have to keep track of, all right? Let me see, I'm going to show y'all something. Bring up my Cal 2 notes. Let's look at my Cal 2. Yeah, so let's see here. Okay, so this was a Cal 2 problem right here. Y'all see this? That right there. This is the problem that we were doing in Cal 2. And this was our first step. Do you see our first step? Long division. We took x cubed plus x and we divided it by x minus 1. Okay, that was our very first step of the problem. And this was our answer with the remainder there. And so what we did is we rewrote this as this, and then we did calculus to it. You don't need to worry about that part. Let's see, next problem. Here's another problem we did. And our first step was long division. See it? We didn't sit there and spend time going over long division. I just went right to it, right? And we just did it. Let's see, that's still the same problem. Yeah, here's a different problem. We actually did not need long division there. Yeah, okay, so I'm just trying to show you that it pops up later, okay? It does. All right, moving on. We now want to talk about synthetic division, all right? Synthetic division. All right, so what is synthetic division? Synthetic division is a shorter way of doing what we just did, okay? This is a shorter method for doing long division. All right. So you might be thinking, well, why show you long division if I'm about to show you a shorter way, right? But it can only be used if the denominator is linear. What do I mean? I mean this: if we have a polynomial divided by something that looks like this, x either plus or minus a. It doesn't matter if it's a plus a or a minus a. If we're taking the polynomial and dividing it by a linear expression, when I say linear, I mean, look at the denominator. The power on x is 1, right? The power on x is 1. That's what makes it linear. If this power were like x squared, can't use synthetic. If it was x cubed, can't use synthetic. So if you look at the problems that we just did, I could have used synthetic here. I could have, because the bottom is linear. This one, nope, no synthetic. Look at the denominator is quadratic, can't do it. The one we did before, nope, no synthetic, okay? Because the denominator is not linear. This one, yes or no? Synthetic. Yes, okay? So let's do this one. Okay, I'm going to do this one because we're allowed to. I'm going to do it with the synthetic division instead. And the way that I think the best way to teach synthetic division is just by example. If I try and actually write like the steps for it, it wouldn't make any sense. It's easier if you just see it happen. Okay, you ready? Synthetic division. Here's the way it works. We're going to do like a division box, just like we did a second ago. But it's going to be upside down, and you're going to give yourself enough space in that box for 2 rows. Okay, we're going to have a row here and a row here. The top row is going to be the coefficients of the numerator, meaning 6, -7, whatever number's in front of that, and then this number by itself. So I'm going to put here 6, -7, 1, 1. Remember, there's a 1 in front of that x, right? All you do is put the coefficients. Go with me? Alyssa, you're looking like, is this all right? You all right? Okay. So you put the coefficients of the numerator in the upside down division box. On the outside of the division box, what you're going to do is you're going to put the opposite of this number. So that's a +2. I'm going to put a -2 out here. Now, look, I mean, if you're sitting there going, what the hell's going on? This is synthetic division, all right? Let's just do it, and we'll talk about, you know, how it's useful, all right? All right, here's how it goes. Once you have this set up, here's what you do. First step. You drop this number straight down and you put it right here, 6. Whatever that number is, you just drop it down. Then you multiply that -2 times that. I'm gonna put an M here for multiply. You multiply -2 times 6. What's -2 times 6? -12, right? You put that answer underneath here. You put it there. Then you add these 2 numbers down again. So what's -7 plus -12? Or you could say -7 take away -12. What would that be?
-19.
-19. You put that here. Okay. And now you do the same thing you did with the 6. You take the -2 and you multiply it times this. What's -2 times -19? 38, right? +38. You put that answer underneath here, 38. You add down again. 1 plus 38 is 39. And then you do this. I know this is starting to look like a complete disaster. You put this, you multiply that times that. -2 times -39 is, I'm sorry, -2 times +39 is
-78.
-78. You put that here. And then your final step, you add that down, you should get -77. Hey, -77. This last number, we usually put a box like this around it, like this. This is always going to be your remainder. Go back and look at the problem when we did it, right here. Do you remember we got -77 down here? Right? We just got that doing this method. Now, this may not seem like it's faster, but trust me, once you get going with synthetic, this can go very quickly. All right, so we have a remainder. So that tells us, because the remainder is not 0, that tells us that it does not, like, we can't factor it, so to speak. But more importantly, I want you to focus your attention on something real quick. Do you see these numbers we have here? 6, -19, and 39. You see those numbers? Do those look familiar? 6x squared minus 19x plus 39. You see that? These numbers are actually the coefficients of that first part of the synthetic division. So what I can do is, from this, I can tell you that I would have had a 6x squared minus 19x plus 39, right? And then plus my remainder, -77, over my divisor. Now, what was my divisor? I have to go back to this over here. My divisor was x plus 2. Do you see how I did that? I used these numbers to determine, to match up with this same thing we got here, 6x squared minus 19x plus 39, and then my remainder, and then this was our answer, right? That was our answer. That matches exactly what I wrote just now. Now, little subtlety here. Why did I put 6x squared here and not 6x cubed, right? Or 6x to the 4th? Why did I put 6x squared? The reason I put 6x squared is because when you do synthetic division, this first number, the power on the x will always be, always, 1 less. Okay, so the numerator had an x cubed, right? That means this first number, it'll be 6x squared. If this was x to the 5th, this would be 6x to the 4th. If this was 6x to the 7th, this would be 6x to the 6th. Okay, then the rest of them are just they just keep going down. The powers keep going down. So the answer to this question, right? The answer to this question is this line right here. Let's do another one, yeah? Let's do this one. Because remember, we did this, I think this was the first problem we did. We got the answer of x plus 1. We should be able to do this with synthetic division, right? We can do this with synthetic because the bottom is linear. Okay, here we go. Upside down box. What are the numbers that go in the box?
1, -2, and -3.
1, -2, -3. What number goes on the outside of the box?
+3.
+3. Okay. See if you can do it. I'll give you 30 seconds. Give me a yes on the poll if you finish this. Okay, I've got about 10 of you done. I'm gonna work it, and I'm gonna work it fast, okay? Just to show you how quick synthetic should go. All right, so here we go. 1 comes down, 1 times 3 is 3, put it under here. -2 + 3 is 1, 3 times 1 is 3, add down 0. I have no remainder, right? Now, what does this turn into and this turn into? If this started as x squared, this first one's going to be 1 what?
X.
X.
Just x, right? And then I'm going to have plus 1. And that's just x plus 1, right? And wasn't that our answer earlier? Yeah, it was x plus 1, wasn't it? So that's our answer. Does everyone understand that's our answer? But more importantly, for where we're headed, more importantly, I want you to think about this, okay? Focus all of your attention right here on this box. What this box really tells me is this, that if I take this answer, x plus 1, and I use this, the knowledge of where that 3 came from. Remember, the 3 came from the opposite of what was down here, right? Then I could put next to this x minus 3. And this right here is the factored form of the top, isn't it? In other words, I can use just the synthetic division box to create the completely factored form of the numerator. That's extremely powerful, as we're about to see, all right? Let's do one more example before I give you the big result here today. Let's do this one. I want us to take 2x squared minus 5x plus 2. And I want us to divide this by, hold on. Hold on for a second here. I want to make sure I get this right. I don't want to mess this up. 2. Okay. Okay, I want us to divide this by x minus 2. Okay. I can use synthetic division because the bottom is linear. 2, -5, 2. Outside 2. Crank it out. I'll give you 30 seconds. I'm not going to do a poll. Just see what you can do in 30 seconds. Isn't this better than long division? Okay, 2 times 2 is 4, add down -1, -2, check it out, 0, 0, that's good. So this means that I have 2x minus 1 is my answer. That would be the answer to the question, right? That would be the answer to the question, 2x minus 1. That would be the answer. But again, for where we're headed, more importantly, I know that this tells me that x minus, oops, forgot the x minus 2 times 2x minus 1 is the factored version of the numerator, right? What I'm trying to get y'all to see here is that, you remember in the past, I came into this class and I said, hey, everyone here needs to know how to factor a quadratic, right? And have a method. You can actually use this method to factor quadratics, but there's one big catch. The big catch is, well, you'll see. What if I gave you this? You know, ready? All right. What if I gave you 2x squared minus 5x plus 2, and I ask you to factor it? We know the answer, right? The answer is this. But how are you going to use synthetic division? Because I'm not telling you to divide anything, am I? I'm just saying, hey, go factor this. So how in the world are you going to come up with using 2 out here, right? I mean, you know that in the synthetic division box, you'll have 2, -5, 2, but how do you know to use 2 out here? Because if you use a different number, it's not going to work. If you try a 3, you won't get a remainder of 0. So how do you know 2? Do y'all understand what I'm getting at? Like, where does that idea to put a 2 out there come from? So here's how we can do this. We do 2, -5, 2, right? That's what we put in there. The question is, what number goes on the outside, right? What number goes here? What number goes there? Well, guess what? We have something called the rational zero test. The rational zero test. Now, you're not going to like this, okay, initially, but it's not as bad as it actually looks, okay? And it actually gives you like a way of doing it. Like right now, we just don't know what number to put out there. We don't want to start guessing numbers, right? There's an infinite number of numbers that we could guess. So the rational zero test, what it does, this test gives you a list of numbers to try. All right. That's what the rational zero test does. It gives you a list of numbers to try in the synthetic division. Unfortunately, it doesn't tell you that it's not going to give you like, oh, here's the number you should use. It gives you a list of numbers and then you're going to try them. So the question is, you know, how do we come up with this list, right? Here it comes. What you're going to do is this. You're first going to look at the number in the back, 2. And I don't even care if it's positive or negative. Just write the number 2 down. I'm going to put a colon next to it. I want you to list out all the factors of 2, all the numbers that you multiply together to get 2. So you could do 1 times 2, right? You could do 1 times 2. So 1 and 2 are both factors. And then you could also do -1 times -2, couldn't you? So I'm going to put, it could be either a positive or a -1 or a positive or a -2. That's it. Those are the only factors of 2. All right. Not done. Now you have to take the number in front, which is also 2, and list all the factors of that number, which happens to be the exact same list, ±1, ±2. Okay. So far we've created 2 sets of numbers. The first number came from the yellow 2 on the back, and the second set of numbers came from the green 2 up on the front. With me? Your final list is going to be all of the numbers here divided by all of the numbers here. Okay, that's weird. I'm going to write it this way. ±1 ±2 divided by ±1 ±2. Now this is a weird, this is a weird notation. What it really means is first start with this number right here. Okay, start with 1 and let's do ±1 over ±1. What would happen if you take ±1 and divide it by +or-1? What would you get? +or-1, right? Depending on how you do it, you're going to get +or-1. Now do the same number, +or-1, but now over the 2. So what's +or-1 over +or-2? Well, that would be ±1/2. So again, what I've done here is I've taken the 1 and I've divided that 1 by both of these numbers. And I created these 2 things, right? Then I go to the second number and I do the same thing. What's plus or minus 2 over plus or minus 1? Plus or minus 2, right? Lastly, I do plus or minus 2 over plus or minus 2. But wouldn't that just be plus or minus 1? Yeah. So how would you say how would I say you get the final list? The final list is all numbers from top list divided by all numbers from bottom list. Does that make sense to everyone? You're gonna take all the numbers from the top list and divide them by all the numbers on the bottom list. And you're gonna create this new list of numbers. This is it right here. How many numbers are there? How many numbers are in that list? You have to look at both the plus and minus though. So it's double what you see there. So there's 6 possible numbers. All right. There's 6 possible numbers there. Okay, so where do we start, right? Like, where do you start? Well, let's just go back up to this synthetic division. Okay, we didn't know what number to put out here. Let's start with +1. Okay, let's start with +1.
So I have a quick question.
Yes.
That list or like the twos or whatever,
Mhm.
the top list or the first 2, does it have to be the last number 2 or like the last coefficient?
Yeah, the top list has to be the last number, the coefficient, and the bottom list is going to be the first one. So this is going to be our top list. This is going to be our bottom list. And the top list comes from there and the bottom list comes from there always.
Got that.
Okay. So I'm going to take this synthetic division and I'm going to do the synthetic division starting with 1. And now that I'm really fast with this, I'm going to see what happens. 2 comes down, 1 times 2 is 2. Add down, I get -3. 1 times -3 is -3. And when I add down there, I get -1. And you know what? That's not 0, right? Didn't work. Now I try -1. Yes, you have to do this like repeatedly. Sorry, I wish I had better news for you. Okay. And bring down the 2, that's -2, that's -7, that's 7, that's 9. That doesn't work. I'm going to skip the fraction. Okay. And I would recommend that you skip the fractions as well. Just maybe, you know, because they'll be harder to work with. Let's go with 2. Right? Let's go with 2. So if we do 2, we get 2 here, we get 4, we get -1, we get -2, and hey, we got our 0. Was that what we did earlier? Yeah, I mean, we already knew this would happen, right? Okay, but now we know. Now at this point, here's what we know. We're happy, right? We're like, yay, we got 0 here. So that tells us, this information tells us that 2x minus 1 is a factor. And that information tells us that x, not +2, but -2 is a factor. And we have now factored it. Okay. I have 15 minutes. I'm gonna try to get 2 more of these in. Are there questions? To factor this, now what we know is that we can create this list using the rational 0 test. We can then use the list to keep trying those numbers until we get a 0. Once we get a 0, we are there. We have factored. I'm going to give you another one. Now this one is going to be, it's not, the idea of this one's not to be hard, okay? It's just to show you, just to make sure you're doing it correctly on the synthetic division. Everyone here should know that that's a difference of squares, right? And so we know how this factors, x plus 2, x minus 2, right? We're all comfortable with that? But I'm gonna do it with synthetic. I'm gonna take this. What are the numbers that go in there? Zachary, you look like I'm putting you to sleep here, so what do you, I'm gonna get you involved, kind of get your blood flowing here. What numbers go in the synthetic division box there?
It's from inside or outside?
The inside here. What am I gonna put in
So
here?
1 and 4.
One and
One on -4.
-4. Okay, now I gave you everyone this one just almost to try and trick you. I agree that there is a 1 and a -4 there, but Zachary, do you see that we're missing an X term?
Oh
There's
yeah,
no X term, right?
yeah. There's a 0 as well.
Good. You need a 0 here and then a -4. So you have to pay attention. Just like when we were doing long division, if you're missing a term, you have to put a 0 in the synthetic division. Make sense?
Yeah.
Okay. Now, the number on the outside, Zachary, you're good. I just wanted to kind of get you involved to kind of, get you going there.
Yeah. Sorry, I didn't have a good night's sleep
It's
last
okay.
night.
It's okay. I'm just trying to help you, kind of wake up a little bit. I'm going to have 2 lists here, right, everyone? The first list is going to come from this number. I don't care that it's -4. I'm just going to look at the number 4 itself, right? That's my first. What are all the possible factors of 4? One and 4, right? 1 and 4.
And
1
2
and 4.
or 2 and 2.
And 2 and 2. So I can go, I'm going to write it this way, ±1. I'm going to put the ±4 here on the end. And then I also know that ±2. I don't have to write 2 twice. Even though it's like 2 times 2, I get it, but I only have to write the 2 one time. So those are the only numbers that divide into 4 evenly, is basically what we're asking. And then what about the number in front? Well, it's a 1, right? It's a 1, and this is the best case scenario. Whenever you have a 1, what's nice is the only factors 1 are positive and -1. So when you create your final list from these, you've got to take all of those and divide each of those by what? ±1, but that doesn't change it, right? That just leaves those. So anytime your leading coefficient is a 1, your final list is really just the top list, this one right here. So what's good here is that we only have 6 candidates, don't we? We have 6 candidates for this. So now we just need to be quick with this. I'm going to start with 1. Then I know it's not going to work. And then I'm going to do -1. And then I know that's not going to work either. And then I'll get to 2. 2 will work, but let's just work these. So I'm starting with 1, put a 1 out here, bring the 1 down. 1 times 1 is 1, bring 0 plus 1 is 1, 1 times 1 is 1, and then add down, we get -3. Doesn't work. Try -1, bring the 1 down, multiply -1, add down -1, multiply +1, add down -3. I know I'm going fast, okay? Here, bring down 1, that's a 2, add down 2, 2 times 2 is 4, there we go. It worked. So now we interpret this. These 2 come down and tell me I have Zane.
Yes.
Okay, so Zane, what do I have? Tell me what this right here, the 1 and the 2, tell me I have here.
X plus 2.
Okay, and then what does this tell me I have?
X minus 2.
X minus 2. It'll always be the opposite. And that's what we said it was going to be to start, right? Okay. Good, 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 good. Any questions? Let's go back to the problem we got stuck on last class. This one right here. We did not know how to factor this, did we? Let me just remind you, we were trying to sketch this polynomial. The first thing we did was we used the leading coefficient test. We looked at the degree, we looked at the leading coefficient. It told us that the left side went up, right side went down. If you don't remember, just go back and review your notes and video from last time. But the second step was setting this equal to 0. So when we set it to 0, the first thing we did was we pulled in negative x squared out. Great, but that left us with this and we didn't know how to factor it. Now we have an actual method. We have an attack for this now, right? We have a way to attack it. So I want us to go now and see if we can't factor this. Okay, let's see if we can factor this. I think we might be able to. So I want us to factor. So let's start with the lists, right? Because we know we're going to need the lists for synthetic. So I'm going to start with the number in the back, 36. I'm going to list out all the factors of 36. And there's quite a few. I always start with 1. 1 and 36, right? Those are factors. I could do 1 and 1, I could do -1. I'm sorry, I could do 1 and 36 or -1 and -36. What else goes into 36?
2 and 18.
2 and 18. So I could go ±2 here. I could do ±18. I like to do it this way, where I work from the outside and I bring it in, because eventually you're going to meet in the middle. How about 3? Does 3 go into this?
Yeah,
Yeah,
6
right.
times.
3 and what?
9.
9.
3 and 12.
12.
Yeah. Does 4 go into that? 4 and 9, right?
Yeah.
I may have not given myself enough room here. Anything else? 5 doesn't go into it, right? How about 6? 6 times 6, right? Holy shit. That's my list. Each one of those numbers represents 2 possibilities. So this is 2, 4, 6, 8, 10, 12, 14, 16, 18. There are 18 possible things for us to use for synthetic division, right? Which sucks, but look, it's better than your other option, which is you can't factor it, right? I mean, that's your other option, is you don't know how to do it. So where do you start? I don't know. Let's start at 1, okay? And then if 1 doesn't work, let's go to -1. If -1 doesn't work, let's go to 2. And then if 2 doesn't work, -2. And let's just work our way through the list. Now, there are some things I could teach you to be a little bit less kind of shooting in the dark here, like how you can eliminate some of these, but the time it takes to go through that isn't worth what you gain. I think just crank these out, just go with it. Okay, I think I wrote everything down correctly, right? 1, -2, -15, 36. We didn't have any gaps in here, right? We had x cubed, x squared, x number, so no zeros. And let's go. I'll do one of them here. 1 times 1 is 1, -1. That's going to be -1. That's -16, and that's -16. Nope, it's not happening there. Let me go to -1. So 1 comes down, -1. It's -3. That's going to be 3. That's going to be -12, and that's not working. Okay. Does anyone have it yet? What works? No one's there yet. I'm going to go to 2. Okay, 2 times 1 is 2. That gives me a 0. 2 times 0 is 0. That gives me -15. No, that doesn't work. That's -30. Okay, that doesn't work. Come on. One, -2 here. That's -4. That's 8. 8, that's -7, and that's +14. Doesn't work. Oh my goodness. 3. 1, 3, 1, 3, -12. Ah, I got it. -36. There we go. 0. 3 works. Are we happy? We got one to work. Questions on that? Does everyone see why it works? 1 comes down, 3 times 1 is 3, add down, you get 1, 3 times 1 is 3, add down, you get -12, 3 times -12 is -36, add down, you get 0.
I have a question.
Yes,
I have a question more about my method on how I do it, because this is how I did it when I learned it in high school. Well, so what I do is like, because like how you go through an individual like number starting, because that's really what it is, it's trial and error.
Yeah.
I try to find the middle number,
Mhm.
and I'll go from there. And if I have a big like depending on my remainder size, it depends on like I basically like cut it in half of which one I know. So if like I started with 6 and I realized 6 was too much, so then I threw away the other ones and went straight down to 4. And
Yeah.
found 3. Like is that like a good
Yeah,
method, or is that
you
like a
can do
risky-
that. It really doesn't matter where you start. Like I said, there are some things I could teach you that would kind of help you to see which one to pick, okay? But what's more important is that we have a list of 18 things, and like if it's gonna work, we're gonna get to it eventually.
Yeah.
When I give you a test, okay, when I give you an exam, I promise that it's gonna work within the first 2 or 3 numbers. In other words, if you start and you move from left to right on the exam, I promise it's gonna happen within the first 2 or 3. I won't make it be the very last number you choose, all right? I won't make you go through 18 of them to get to it. But use whatever you're comfortable with. If that's what you want to do, go ahead. I'm giving you some indication on the test of what I'm going to do. Okay, we're not done, right? We're not done, because what does this tell us? Well, this tells us right here something, and this tells us something, right? Now notice we have 3 numbers, right? Instead of 2, we've had 2 quite a few times here. We go back to where we started. We were trying to factor this, and it had a cubed on it, didn't it? It had cubed, which means that when we look at this synthetic division result down here, this 1 is going to be in front of a what?
X squared.
X squared. Good. So this is going to be 1x squared. I'm not going to write the 1. That's 1x squared plus, okay, what is this 1 in front of?
X.
X, and then the -12, okay? That's all in parentheses. And then this piece out front tells us X -3. So this is pretty incredible. What we've done is we've taken this expression here, right? This polynomial. This is where we were, right? We were looking at this and we were stuck. We were trying to figure out when it was equal to 0. But now what I know is that this is x plus 3, sorry, x minus 3, times x squared plus x minus 12, right? And because I'm pretty decent at factoring, I realized that this could be factored as x plus 4 times x minus 3. So this factoring I did right here, I did in my head, but couldn't you actually do synthetic division on that? If you had to, couldn't you just take this and start synthetic division again? If you didn't know how to factor it, you could, right? But x squared plus 12, I mean, plus x minus 12 should be something you feel comfortable factoring. So check it out. We are here. This is the factored form of this blue thing. So if we go back to last class when we were stuck here, right? We were stuck. What we can say now is that this is now that. And don't forget, we had the negative x squared out front, and that's equal to 0. So now we can set each of these equal to 0 and get the multiplicity to determine if it bounces or crosses. We'll continue this next class. I don't want us to get into this because we're done as far as time. But I hope that you can appreciate the power of what we have now in our toolbox. The synthetic division is extremely powerful when it comes to factoring things. I know the long division's, tedious, but synthetic division is extremely important. And so next class, what we will do is we will go back to sketching polynomials. But now we'll have this new tool for factoring. So anything we face, we should be pretty okay with. All right. Your homework for tonight, I didn't get to go over any of the homework for synthetic division. I didn't show you any examples from the homework, but you know how to do it now. And you should be okay with it. So this homework assignment is still what I expect for you to do before we meet again next time. Have a great weekend, right? It's Wednesday. So you'll have a great weekend. I'll see you on Monday.
Have a good weekend.
You as well.
I have a question.
Yes.